Hello everyone! This video will explore the topic of logarithms and what to do with them in certain situations. Logarithms, or logs for short, are used to rearrange exponential equations to make them solvable. You may have heard of an acronym that was used to help remember this form, BEN is your friend. BEN stands for base, exponent, and number. These parts are labeled in the following formulas. The exponential form is b to the e equals n. This can be placed into a logarithm by the other forms. The log of base b of n equals e, and the ln of n equals e. Logarithms have a base of 10, and natural logarithms, written as ln, have a base of e. E is simply a symbol for a number like pi is, and it is equal to approximately 2.718. Let's say we're looking at ln of e equals 1. Another way to remember how to set up this logarithm is if you read them in this way. The exponent on the base e of e is 1. The smaller e underneath the ln does not need to be written because ln is known to have a base of e, otherwise it would be a logarithm. Now that we know what defines a logarithm and the natural logarithm, let's tackle some examples using exponential equations. Our first problem is the log of base 2 of 16 equals x. First, we need to rewrite the equation in its exponential form so it can be solvable. Using the BEN format we saw before, the base, or b, would be equal to 2. The number n would be 16, and the exponent e would be x. So the equation would be rewritten as 2 to the x equals 16. Now we can think about what number 2 will be raised to in order to get 16. When 2 is raised to the fourth power, it equals 16, so the equation can be written as 2 to the x equals 2 to the fourth. And 4 is your answer. But what if the exponent we needed was not as simple, and you didn't know what number could give you the answer? We have the equation the log of base x of 243 equals 5, which can be written as x to the fifth equals 243. But don't get stumped. With a small review of exponent rules, when a number with an exponent is raised to a power, the exponents are multiplied. As a result, we can raise both sides of the equation to the 1/5 power, which will cancel out the 5 the x is raised to. Also, raising something to an exponent with a fraction raises it to a power depending on the numerator and takes the root of it depending on the denominator. So a 1/5 power takes the fifth root of 243, and our answer is 3. Sometimes you will see equations that need to be expanded or simplified or written with logs or without them. There are special rules that are used when an equation is written as a fully expanded logarithm. First, x times y equals the log of x plus the log of y. Next, x divided by y equals the log of x minus the log of y. And finally, x to the y power equals y times the log of x. Here's a problem that combines all of these rules together. G equals a cubed times b over c. The key to answering these types of questions is knowing when to use each rule. Let's start with the numerator first. There are two variables being multiplied together, and a is being raised to the third power. So when everything is placed in logarithmic form, the log of a will be multiplied by 3 and added to the log of b, giving us the log of g equals 3 times the log of a plus the log of b over c. Next, in the original equation, the numerator is divided by c, and our rule states that when the variables are divided, it is subtracting in logarithms. So we would subtract the log of c from 3 times the log of a plus the log of b. When giving exponential equations in a word problem, logarithms will have to be used to solve them by hand. The growth of a certain string of bacteria is modeled by the equation g equals a times 2.7 to the 0.584 times t power. where G equals the final number of bacteria, A equals the initial number of bacteria, and T equals the time in hours. In approximately how many hours will 4 bacteria first increase to 2,500 bacteria? Record your answer to the nearest hour. From the information in the question, we can substitute the variables with their corresponding numbers. So we know that G is 2,500 and A is 4. We need to solve for T. So our equation would be 2,500 equals 4 times 2.7 raised to the 0.584 times T power, which can be simplified by dividing both sides by 4 to get 625 equals 2.7 to the 0.584 times T power. Next, rewrite using logarithmic form or the log of b times n equals e. So it is 0.584t equals the log of base 2.7 of 625. To simplify a logarithm with the base, you will need to use the change of base formula. The change of base formula is that the base x of y equals the log of y over the log of x. We plug in 2.7 for x and 625 for y, and 0.584 times t equals the log of 625 over the log of 2.7. Then put the right side of the equation into a calculator and divide it by 0.584, and t is about 11 hours. And that's it for this video. Thanks for watching, and if you have any questions or suggestions for other video topics, feel free to leave them in the comments. Please subscribe if you'd like to see more from us in the future.